Okay, hi class. This is Mr. Krieger. This is the next lesson for AP Statistics, Unit 4, Lesson 2. It's the chi-square test of independence. I'm going to try to do this video I'm going to try to do this in 2 videos, so we'll see how that works out. Okay, so if we go to the first page, please print up the lesson and look at the first page. Here's what we're looking for. How can we test a relationship between categorical variables? Here's what we mean. I want you to take a look at this table. We have 2 variables. We have political party association and gender. And we want to see if there's an association between these 2 variables. Basically, is political party independent of gender? Here's how you think about it. If there's about the same percentage of men and women in each party, then the 2 variables are independent of each other. Now, in this particular case, you can see I made it very, very clear that it's not independent. There's drastically more males in the Republican Party and drastically more females in the Democratic Party. These are all other political parties. So the way I've made this is just to clearly see the discrepancy between the 2 variables. Male and female are not independent of the political party, right? In this particular problem, you don't really need to run any tests. You can see it for yourself. We're going to take a look at a case where, what if they're closer and you're not sure if they're independent of each other? That's where the chi-square test actually comes in handy. Here's what we need to do in order to do our chi-square test. We need a single, simple random sample drawn from the population, and the observations are classified according to the 2 categorical variables. So again, political party versus, in this case, gender. But we could basically compare any 2 types of variables. It doesn't have to be gender. It could be anything, right? The Null Hypothesis tests that there's no relationship between this variable and this variable, the political party and gender. And the alternative hypothesis will be, no, there is an association. Like, just looking at this data, we can clearly say there's an association. Men tend to be more heavily Republican and women more heavily Democrat, okay? That's from this extreme example, okay? So let me take a look at, I'm just using this so it doesn't bleed through. Let's take a look at how we do this. So, steps for inference for a 2-way table. You're going to have to arrange the data in the table like this. 1 variable for the columns, 1 variable for the rows, right? We actually call this an R by C table, row and column table. This allows us to compare 2 or more populations. I'm sorry, the comparison of more than 2 populations. This is how you state the hypothesis. The null hypothesis states that there is no association between the 2 categorical variables. In your specific problem, you're going to say, like the one we're doing here, there is no association between gender and political party. That's for our particular problem. And the alternative hypothesis, you would say, there is an association between the 2 variables. Now remember, the null hypothesis is always that no association, nothing's going on. We shouldn't expect anything. That's the null. And the alternative is when we have a very small p-value, a large chi-squared value, that we would reject the null and favor the alternative, okay? Now, if you remember that in order to do a chi-square test, you need observed values. These are our observed values. But you also need expected values. So I'm going to show you now how to create expected values. The calculator is largely going to do this for you, but I'm going to quickly show you how you can actually figure it out on your own. So you are always going to, on a test, or especially on the AP exam, make the expected value table. And it's going to look just like the table you had, with the exception of, instead of having the actual counts, they're going to be the expected value counts. So here you have male, female. Here you have Republican, Democrat, and other. And just think about how this is going to be. Here, the distribution of Republicans among men and women are heavily toward Republican. But there are 26 people in this category, and if we split them evenly, if there were really no difference, we would expect the values for male and female Republicans to be 13 each. In other words, take the total and divide it evenly into these male or female categories. Same thing for the Democrats. Here there's 26, so again it's going to be 13 and 13. And the others, there's 2, and that actually was the same as the actual values. So this is how you create the expected value table, but I just wanted you to be aware, you're generally not going to have to make this table yourself. The calculator is going to do it for you, okay? So, couple of things you got to know about using this chi-square test. We're not going to have to do the computations, but just so you understand what a chi-square statistic is, it's basically seeing how far away the observed values are from the expected values. If they're very far away from each other, you're going to get a large chi-square statistic, and which means that, no, the observed values and the expected values are very different. These two variables are clearly different, not dependent on each other. We would reject the null. And if these numbers are relatively close together, then we don't really have evidence that the variables are not independent. They would be independent of each other, and that's what they wouldn't be independent of each other, because if these were very similar, you'd say, yeah, there was no difference. Men and women have the same kind of political affiliations. All right. Importantly, how do we create our degrees of freedom? That's actually a little different here than what you would have done in the past. To do degrees of freedom, you take the number of rows. I'm going to put this back under here. You take the number of rows, subtract 1, and you take the number of columns and you subtract 1. And you multiply that together, and that is your degrees of freedom. So in our case, we have 2 rows. So 2 minus 1 is 1. Number of columns is 3. 3 minus 1 is 2. This becomes 1 times 2 is 2. This is the degrees of freedom you would use in order to, when you run the chi-square test. It's going to ask you for the degrees of freedom, so you would need that. And always especially on an AP test, show the expected values table, which you don't have to compute yourself. You'll get it from the calculator. I'll show you in a little bit how. And degrees of freedom. And again, I think the calculator does show you the degrees of freedom, so you won't have to show the calculation, but you can see it's very simple, but you're going to have to write that down too. Okay, I'm going to pause here. I'm going to make a second video.